Now let us discuss the construction of Smith chart. Now what I am going to do is, I am going to construct a Smith chart using the circles that I obtained for constant resistances and the circles that I am obtained for constant reactances. Now how do I do it? What I am going to do is, I am going to superimpose the two circles and create one particular circle. Let's do that. So how do I do it? So you can clearly see, before I get into the discussion of that, you can see this pattern of circles that I've got for the values Rn is equal to 0. See, what is Rn? Rn here indicates the resistive part of the normalized impedance. So when Rn is equal to 0, I get the biggest circle. And what is the radius of the biggest circle? It's a unit circle. The radius is 1. And when I keep on decreasing Rn, or when I am increasing, I mean, see, I am increasing from 1 by 4, 1 by 2, 1, 2 to infinity, what happens? The radius of the circle reduces and ultimately it becomes 0. Now this is the circular pattern I got for Rn, means constant resistances. In the same way, for constant reactances, you can clearly see I got a particular pattern where for different Rn values, means Xn values, I got different circular patterns, and I am going to superimpose, I am going to mix these two circles, and let's see what I am going to get. The final product that I am getting is the Smith chart. Let's do that. So before I do that, let me draw a circle. This is a circle, and I am going to give, let this be U, this is JB, and this is minus U minus JB. Now let's see, let's draw these circles here. So what is this? The blue color indicates Rn is equal to 2, Rn is equal to 0. So this is the first circle I have got. Now for Rn is equal to 1 by 4, what do I do? Let's do it. This is Rn is equal to 1 by 4. Now when I take Rn is equal to 1 by 2, how the circle looks? Let's do that. This is Rn is equal to 1 by 2. When Rn is equal to 1 by 2, I get this circle. When Rn is equal to 1 by 4, I get this circle. When Rn is equal to 0, I get the bigger circle of radius 1. Now when Rn is equal to 1, I am getting a circle in this way. What is this? Rn is equal to 1. And when Rn is equal to 2, I get another circle. This is Rn is equal to 2, and ultimately it is when Rn is equal to infinity, I get the point come and meet at 1, 0. Now this is what I have got. Now what I am going to do is, I am going to superimpose these circles here. Now let's see, while superimposing, observe carefully, I will be only focusing on the red lines that is inside this unit area. So let's put it here. How will it look? Let's see that. Now you can observe here how it looks. You can clearly see how it is observing. It goes in this way, and I have something like this. So what I am basically doing here is that I am neglecting all the red lines that is outside the unit circle. I am only drawing whatever the red lines are there inside the unit circle. And what are these red lines? Let's indicate. This is Xn is equal to 1 by 2. So this is, when I take this Xn, what is this value? Xn is equal to 2. This line indicates Xn is equal to 2 that I am drawing here. And what is this? This is Xn is equal to 1. In the same way, what is this line? This line is Xn is equal to 1 by 2. And what is this line? It is Xn is equal to 1 by 4. And in the same way, you can see this line is what? It's Xn is equal to minus 1 by 4. And this line is Xn is equal to minus 1 by 2. And what is this line? This is you can see this line indicates xn is equal to -1 and this is xn is equal to -2, and you can see this is the basic form of Smith chart that I get while superimposing the circles obtained from constant resistances and constant reactances. The upper plane generally gives you an idea of inductive load, and the lower plane gives you, the lower part gives you a capacitive load. So this is basically what we talk as Smith chart. So this is the Smith chart thing. So what we have discussed, what did we do? We superimposed this resistance circles with the reactance circles and you created a Smith chart. This is called as Smith chart. And this Smith chart is used for calculating impedance, admittance, reflection coefficient, and we also use it to calculate the voltage standing wave ratio. The other part will be discussed in the upcoming videos.